Hello, good evening, Alexander.
Hello, sir. Good evening.
Hmm. All right. So, Alexander, we were discussing about the correlation in the previous chapter, and I think we have covered the introduction of the correlation, wherein I have explained the meaning of correlation and the various types of correlation and method by which correlation can be calculated, right?
Yes, sir.
Other than this, we have just a moment. Apart from the introduction part, wherein we have discussed the meaning, types, and methods. In the previous session, we have done few questions based on the Carl Pearson's method, right?
Yes, sir.
Carl Pearson. So which method we have covered in Carl Pearson? So have we covered all the methods of Carl Pearson, or uh, still any other method is left? Basically
Sir,
there are three methods: actual mean method, the direct method, and the shortcut method, and the step deviation method. So have we done question based on all types of methods?
yes, sir.
Okay. All right. So there is only one topic left in this chapter, which is a scatter diagram. So before starting this, I want you to do one question just to revise the entire concept of the chapter. So we'll be doing one more question based on the step deviation method only, and then we will start with the scatter diagram. So scatter diagram is pretty simple. It won't take a long time to finish it off. So we will probably we will finish this chapter today. So, just tell me one more thing. Have we do we have any other topic left other than the correlation? I think we have some portion of the
Disperse.
dispersion. Yeah. Okay. Okay. All right. So let's just do a question quickly. Then we will do the scatter diagram, and then we will start with the remaining part of the dispersion.
Okay, sir.
Find correlation using Carl Pearson's method. Okay, so this is the question, Alexander. We need to solve this question applying the step deviation method. So as usual, first of all, we will write this question in the vertical format, and after writing it in the vertical format, then we will write down the formula for finding out the correlation by step deviation method, and then we will decide what step we have to take, and accordingly we will make the different columns. So first of all, just write it in the vertical format. Okay. After writing down the question in the vertical format, now we will write down the formula. So formula for calculating correlation by subdivision method is sigma dx dash dy dash minus sigma dx dash multiplied with sigma dy dash divided by number of items, and this entire section will be divided by the under root sigma dx dash square minus sigma dx dash whole square divided by n, and divided by sigma dy dash square minus sigma dy dash square divided by n. Right, Alexander? So you remember the formula, na?
Yes, sir.
Yeah, okay. So could you please tell me what we have to do first?
So dx
We will have to
dash
find out the dx. Okay. So first of all, we will find out dx. Okay. After finding out, and how do we find out dx actually?
from assumed mean.
By subtracting the assumed mean from the items. So x
Yes.
minus a. So let's say, let's suppose 5 is the assumed mean. You can take any other value also. So I'm taking 5 as the assumed mean. After calculating dx, then after calculating dx, what I'll be doing that after that?
Dx dash
Dx dash. Okay. And for that purpose, I have to divide the entire dx with the
common factor.
common factor, correct? And I'll be taking the common factor from the value of the dx. Okay. And after finding out the dx, I'll be calculating the dy, right?
Yes.
So dy. And for that purpose, I'll be subtracting the assumed mean from the items of y variables, and thereafter I'll calculate dy dash. Okay, and after calculating dy dash, I'll be multiplying the dx dash by dy dash, and then I'll doing the square of the dx dash to find out the dx dash square, and then after dy dash square. So these are the steps that I'll be required to take in order to find out the correlation in this question. So I'm giving you 5-10 minutes to solve this. Quickly find out all these and then tell me the answer.
Okay.
Okay. Do it quickly because we need to finish this chapter today by doing the scatter diagram. Then we will start with the remaining part of this portion.
Sir,
Mm-hmm.
do we take the highest common factor or the lowest?
Yeah. We should take the highest common factor from the dx.
Okay.
So could you just tell me what are the values you have got in the for dx?
Yes, sir. 20, 10, 35, 0, 5, 15,
All right. So what will be the common factor?
5.
5 will be the common factor, right? Okay. Done, Alexander. Tell me the value of the dy.
Yes, sir.
Mm-hmm.
30,
30.
yeah,
Okay.
30, 0, 50, 70, 10, 20, 40.
And dy dash, what is the common factor you have taken?
Um, 10.
Okay. 3, 0, 5, 7, 1, 2, and 4. Right? Then
Yes,
we
sir.
will square it. 3, 9, 0, 25, 49, 1, 4, and 16. Okay. After that, we need to find out the dx dy dash. So dx dash and dy dash, 4 3s are 12, 0, 35, then 0, then 1, 6, and 20. Right? Okay, tell me the total of the sigma dx dash.
So 22.
22, and sigma dy dash.
22.
22. Okay,
Yes, sir.
and sigma dx dash dy dash.
74.
74, and sigma dy dash square.
I didn't do it.
You didn't do it, so it will be 34 plus 49. 5 plus 16, so it should be 104. 104. Okay, after that you are just required to put these value and calculate the answer, so you will be able to do that now.
Yes, sir.
Okay, so shall we skip and move to the next topic?
Okay.
Okay, all right, so moving on to the next topic, which is scatter diagram. Okay, so what is actually a scatter diagram is? So we can define the scatter diagram as a scatter diagram is a simple visual method. Let's write down the definition first. A scatter diagram is a simple visual method to determine to establish some idea about the correlation between two variables. Okay. So until now we were actually calculating the correlation. We were applying the formula and we tried to find out the exact degree of correlation between two variables. So by scatter diagram method, we won't be able to calculate the exact degree of correlation or the exact. We won't be able to figure out to what extent exactly two variables are interrelated. But scatter diagram is useful from the viewpoint that it helps us in establishing it will help you to establish some idea about the correlation between two variables. So like you will be able to determine whether two variables are positively correlated or negatively correlated, number one, and you will be able to identify what kind of to to what extent they are exactly not exactly related, but it will give you a fair idea. As for example, let me tell you, for example, this is how we draw the scatter diagram. We take the two axes, y-axis and the x-axis, right? And then we have the variables, values of the variables given in the question. So there will be variables for x and there should be variable for the y as well. Let's suppose, for example, let's take the one variable is price and the other variable is quantity. So you will be provided with the information regarding the two variables. So there will be some value of the price, there will be some information regarding the quantity. All you need to do, using the information, you will be required to plot the values on the diagram. So after plotting the diagram, let's suppose it makes us something, it makes a picture something like this. Let's suppose this kind of diagram is formed, right? So this is called that price and quantity are both are positively related, because see, these dots are going upward. If you connect these dots, you will see that these are aligned in a line and going upward. So that means that all the, I mean, the price and the quantity both are positively related, right? And since they are aligned in a perfect line, so there is a, it is called, there is a perfect correlation, perfect positive correlation between the price and quantity. It will be called perfect positively, perfect positive correlation between price and quantity, right? So let's suppose I make another scatter diagram, and this time diagram is formed something like this. For example, when you plot all the values on the diagram, the values are plotted like this, right? So you can clearly see here, the dots are not aligned in a single line, they are not aligned in a straight line. So it means that these variables are, let's suppose I'm talking about the price and quantity again. So you see that these dots are moving upward, that means it is going from this point to this point. So we will connect, if we connect both these points, just a minute. So we can say that there is a positive, okay, by connecting these dots, the extreme and the initial dot, we can figure out that both, since the dots are going upward, that means there is a positive correlation. But since all the dots are not aligned in a single line, that means there is a partial positive correlation, not perfect positive correlation. Getting my point? So based on the scatter diagram, we are just able to identify what kind of relationship exists between two variables. We won't be able to identify exactly to what extent both the variables are actually related. We won't be able to figure out the exact value of correlation between two variables. We will be able to establish the exact correlation when we apply the formula. Either we have to apply the Spearman's method, or by applying this Carl Pierson method, we will be able to figure out the exact correlation between two variables. But what scatter diagram do, scatter diagram just give you a fair idea that what kind of relationship exists between two variables, whether there is a perfect correlation, negative correlation, partial positive, partial negative. This kind of relationship you will be able to establish on the basis of scatter diagram. Let's suppose when you draw the diagram, and diagram is formed something like this, that all the dots are coming downward from this point, it is moving downward to the, from y-axis it is moving to the x-axis. So that means that two variables are negatively related with each other. If it is going downward, that means two variables are negatively related with each other. And since you can see that all the dots are not aligned in a single line, that means all two variables are negatively related, but not perfectly negatively related, but partial negative relation between two variables is there. You're getting my point, Alexander? What I'm trying to explain you is that on the basis of scatter diagram, we will be able to figure out the correlation between two variable, but not with a you can say we won't be able to figure out the exact degree of correlation, but it just give you a some idea about the correlation between two variable. It won't be able to give you the exact value or exact degree or the extent to which two variables are interrelated. Is that clear to you?
Yes, sir.
Okay, now let's do one thing. Let's do a question based on this. Now then you will be able to understand it in a more proper manner. Just give me a moment. Let me open the question for you. Yeah, okay. So let's do this question. Just a minute. I'll have to write it down. Please note it down. Draw a scatter diagram using from the following information. Four, 5, 6, 7, 8, 9, 10, 11, 12. 6, 7, 8, 9, 10, 11, and 12. Then we have 78, 72. 66, 60, 54, 48, 42, 36, and 30. Okay, so these are the two variables, and the values of two variables are given. And using this information, we need to prepare the scatter diagram. Have you noted this down?
Yes, sir.
Okay. So first of all, let's make a graph. So let me just check. The lowest value is 30 and 78. Okay. All right, so this is the y-axis and this is our x-axis. So we will be plotting the values of x on the x-axis and the values of y variable on the y-axis. But before that, I'll have to take the scaling. So 1, 2, 3, just a minute. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, now on the y-axis, just a minute, on x-axis and y-axis. Okay, on y-axis, let's 10, this will be 0, 10, 20, 30, 40. 0, 10, 20, 30, 40, 50, 60, 70, 80, 90. Okay. All right. Now let's start plotting the values. So first of all, value of x is 4, right? You're able to see this now. Value of x is 4 and value of y is 78. Right, Alexander?
Yes, sir.
So we have to plot this on the graph. 4 on x-axis will be here. Just a minute. 4 and 78. Nah. So 4 and 78. Let's suppose 78 will be somewhere here and 4 will be here. This will be 4 and 78, right?
Yes, sir.
Yeah. So we are not required to draw this line. We will be just plotting the dot. So dot will be somewhere here, indicating that this will be 4 and 78. After that, we have 5 and 72. So let's suppose 72 will be somewhere above the 70 and 5 will be here. So this kind of diagram will be this is where the dot will be formed. Then we have 6 and 66. 6 and 66. So 6 and 66 will be somewhere above 65. So 66 will be somewhere near this point. Okay. After that, we have 7 and 60. 7 and 60. So 7 and 60 will be right here. Then 8 and 54. So 8 is here and 54 will be just below 55. So let's suppose this will be the 54. And then we have 9 and 48. 9 and 48. 9 and 48. Okay. So in order to draw the scatter diagram more accurately, you will be you should have the graph paper. Unless and until you have the graph paper, you won't be able to draw the scatter diagram very accurately. So I'm just giving you the idea how it will be formed. So if you have the graph paper, you will be able to prepare the scatter diagram more accurately. I hope that when this kind of question will be asked in examination, they will be providing you the graph paper. Okay. So you will be provided with the graph paper to solve this question.
Okay, sir.
9 for then 1042. 1042. 10, this is 10 and this will be 42. Okay. Then we have 1136. 11 and 36. 11 and 36. Okay. Then 12 and 30. So 12 and 30. 12 and 30 will be here. Okay. So this is it. This is the scatter diagram. Now you can see that all the dots are almost in a linear line. All the dots are almost aligned in a straight line. So we can call that it is a, just tell me whether it is a positive, there is a positive correlation between x and y or the negative correlation. Since the dots are moving downward, so what you will call
Negative.
it is a negative correlation. And almost all the dots are in a linear line. So we can call it
Perfect.
that it is a perfect negative correlation. Right?
Yes, sir.
So you have to write down the type of correlation between the variables. So we will be writing it here only. Perfectly negative correlation. Okay. So if you wish, you can also draw a line passing all through all these dots, and it is difficult for me to draw a straight line here on the writing pad, but I'm sure you can do it on the notebook using scale. This kind of straight line will be formed, right, Alexander?
Yes, sir.
Okay. So this is what we call scatter diagram. This is it. Okay, I'm giving you one more question. Just try this one and tell me the kind of correlation exists there. Just a minute. Okay, so I'm dictating you the question. Could you please write down?
Okay.
Yeah. So please, yeah, just let me write it down. Just a moment. Values are 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. One, 2, 3, 4, 5, 6, 7, and 8. And for y variables, values are 11, 12, 15, 11, 12, 15, 20, 24, 18, 26, and 29. These are the values. You need to prepare the diagram based on this scatter diagram.
Okay, sir. Sir,
Mm-hmm.
it will be partially positive.
Partially positive. Okay.
Yes.
Okay, Alexander, let me tell you the exact terminology that will be used in such a case. I think your scatter diagram will be something like this, na? It will be something. Is it something like this? Or the dots are not very much scattered now on the diagram?
Yes, sir.
Yeah. So the exact term for that is high degree of positive correlation. Let me explain that part to you. So types of correlation on the basis of diagram, on the basis of scatter diagram. On the basis of a scatter diagram, we can have the perfect positive correlation. Perfect positive correlation means when the dots are going upward and all the dots are positive, all the dots are falling almost in a line, then in that case we call it a perfect positive correlation. Then we have the perfect negative correlation. Perfect negative correlation. Perfect negative correlation actually means that the dots of the variables are coming downwards, and but all the dots are falling almost in a line, exactly on a line, or a little deviation is there on from the line, then it will be called perfectly negative correlation. Then apart from that, we have high degree of positive and low degree of positive correlation as well. So you can say positive correlation can be further divided. We can divide the positive correlation as the high degree of positive correlation, high degree of positive correlation, then we have low degree of positive correlation, low degree of positive correlation. See, when you make the scatter diagram, and scatter diagram looks something like this. Let's suppose when you make the diagram, it looks something like this. That let's suppose this is a straight line. If dots are not falling exactly on the line, let's suppose one dot is here, then the other one is here, then here, then here. Like this. If the dots are closer to the straight line, but not exactly in a straight line, then it will be called that there exists a positive correlation. But since all the dots are not exactly falling on the line, then it will be called high degree of positive correlation, right? And similarly, when you draw the diagram, scatter diagram, and the dots of two variables are lying on the diagram like this. Let's suppose this is a straight line. Suppose I draw a straight line, and when you plot the values of the two variables on the diagram, and diagrams are dots are falling like this. That means there exists a positive correlation. There exists a positive correlation, but all the dots are far from the straight line, not closer at all from if you compare it with the straight line, then you will call it that there is a positive correlation since all the dots are going upward, right? Since the dots are going upward, then therefore it is a positive correlation between the variable, but these dots are not falling near the straight line. That means there is a low degree of correlation. You are able to differentiate between the high degree and the low degree of correlation, Alexander?
Yes, sir.
Yeah. And you also understood the perfect positive correlation. In case of perfect positive correlation, what happens? No, all the dots lies on the straight line exactly, or a very little deviation will be there, right? But in case of high degree, there will be deviation in the dots more than once, and in case of low degree of positive correlation, no dots will be falling on the line. Is it clear to you?
Sir, when majority of the dots are on the line, it means high degree.
Yeah, if majority are on the line, then it will be called high degree. If almost all the dots are on a straight line, it will be called perfectly positive correlation. And if no dot are falling, if the dots are not falling in line at all, the dots are scattered all around on a diagram, it will be called low degree of positive correlation.
Sir, what about partially positive?
Yeah, okay. So this is what partially positive, both are covered in the partially positive correlation part. See, both are called partially positive correlation. Since it is not perfectly, there is no perfect positive correlation, therefore we call it partially positive correlation. But the exact terminology that we use for this case is called high degree of positive correlation, and for that we use the low degree of positive correlation. So collectively both are called the partially positive correlation.
Okay, sir.
Okay. Okay, moving on to the negative correlation. If all the dots are coming downward and falling exactly in a straight line, it will be called perfectly negative correlation. But again, if the dots are majority of the dots are on a line, but few are scattered around, like this, this is called high degree of negative correlation, right? And let's suppose if you make the diagram and dots are like this, very few dots are on a line, then it will be called low degree of negative correlation. Is this clear to you, Alexander?
Yes, sir.
So this is there are basically, you can say there are 6 type of correlation based on the scatter diagram. Either it will be a perfect positive correlation, or the high degree of positive correlation, low degree of positive correlation, 3. Fourth could be perfectly negative correlation. Fifth could be low degree of negative correlation, and then there could be high degree of negative correlation. So there are 6 categories of correlation based on the scatter diagram. So we don't have the exact value to indicate to what extent two variables are interrelated. We can just indicate the relationship between two variables by plotting the values on the diagram, and based on the values that we have plotted on the diagram, we will be able to figure out the correlation between two variables. So I hope it is clear to you, Alexander.
Yes, sir.
Okay, so you just need to do that. I would recommend that you just go through the study material once, and if you find anything difficult, you are not able to understand anything, then let me know in the next session. I hope that when you will cover this topic on your own, you will be able to understand everything. The thing is that I need to we need to practice a few more questions. We have done only 2 questions in the class now. So I would recommend you to do more question from your textbook, and if you face any difficulty solving those, then let me know in the next session. And I would also recommend that you also go through the theoretical part of the scatter diagram. You will have a better idea about the scatter diagram then.
Okay.
Okay, now we have just tell me,